All right, learning target 1.4. Now we want to evaluate the function given in a story form. Okay. So typically what we want to do first is figure out what the function is going to be. Okay. So we'd find some sort of number, right? And we can do it two ways. We can do the starting number first, plus or multiply the growth, times the variable or variable to the power if it was multiplying. Then we determine, are we given an input or an output? If we're given the input, right, then we change it to the number. We do the start plus the growth times that number. And then we evaluate and we get our result. Okay, if we're given the output, we then replace the output, the whole f of x, so whatever that number is, equals the start times the growth to the x. Then we solve it to get x by itself. Okay? So that's kind of the way we want to do this. Alright, so Ms. Hunter takes off 10 points for each day an assignment is turned in late. The assignments are worth 100 points each. How many days late can an assignment be and still get 30 points on it? So let's make our function first. So I'm going to go f of x equals, we start with 100 points. We're subtracting 10 each time. Okay, and you can change these. You could have called this h of L, okay, if you wanted to. It doesn't really matter. Okay, so how many days late can an assignment be and still get 30 points on it? So does that give us, for each day we're subtracting 10. So the L, the input, is really days. So the output would be the points. So h of L would equal 30. So to solve this, I replace that with 30, and then we're going to solve, in this case, for L. So I'd subtract 100, giving me negative 70 equals negative 10 times L. Divide by negative 10, and we get positive 7 equals L. So what does that mean? That means 7 days late would give you a score of 30, or h of 7 equals 30. Okay? And that's how we deal with these ones. Okay, so let's take a look at number 2, give you another example. Okay, so there are 200 ladybugs in a certain population. The population is decreasing by 14% per day. How many will there be in 10 days? So let's make this a g of x equals, we start with 200 ladybugs. Now, we're dealing with a percent, which generally means it's exponential. So it's decreasing by 14% per day, which means every day we subtract 14% from our starting number of 100%, which means we have 86% left. So mathematically speaking, when we change that to a decimal, we're timesing by 0.86 to the x. Now it says how many will there be in 10 days? Well, the days determine how many we have, so days is independent variable, which means it's the input. And number of ladybugs would be the g of x, our output. So I plug in a 10, so g of 10 equals 200 times 0.86 to the 10th. And I'm definitely going to need a calculator on this one. So I pull up my calculator, and I go 0.86 to the 10th, which gives me like 0.22130157888888031. So pretty big decimal. So just using my calculator, I'll take that decimal and I'll just times it by 200. And that gives me 44.26 about. Okay, so in 10 days, they'll basically, because you can't really have 0.2 of a ladybug, they're basically, you're going to have 44. Okay? Alright, so if you haven't yet, try all the rest of these, and let's see how you do. Okay, number 4. Your salary starts at $23,000 and goes up by 5% per year. How many years until you earn $50,000? Okay, so f of x, it's a weird x, would equal, we started with 23,000. Okay, it's going up by 5% a year, which means if we take this 100% next year we're going to have 105% of that. So I times by 1.05 to the x. Now, how many years until you earn 50,000? So to figure that out, that's our output, okay? And we could use guess and check until we get to about 50,000, or we can try to kind of simplify and then solve. Exponentials are very difficult to solve for us, so the best thing we can do is divide by the start number, because that we can do. Okay, and then we're going to kind of guess. So 50,000 divided by 23,000 gives us about 2.1739. Okay, and I abbreviated. So now I'm going to go 1.05, and I'm going to see how many years. Well, let's think. About how many years is it probably going to take? Okay, well, probably at least 10 years. So if we did it to the 10th power, it would be 1.6288. Okay, we need to get up to 2. So we want to maybe try 20 years. So 1.05 to the 20th, which would be, make sure I type that in right. That would be 2.65. So that was 10 years, 20. So we're going to be less than that. Let's try 18. 0.05 to the 18 is 2.4, so less years than that. 1.05 to the 16 would be 2.18. Okay, so probably 16 years. Let's try 1.05 to the 15th. We get 2.07, so I'd probably go with 16 years. So x would equal 16 years. So those exponentials, when you're doing them backwards, those are probably the toughest type to do. Okay, so if you struggle with, don't worry too much. Okay, sorry if the audio was a little weird. I accidentally paused the video in the middle of my sentence. Okay, 4. A painter is going to charge $90 for paint and $35 an hour to paint your kitchen. How long did it take if your bill is $265? Well, we go f of x equals the 90 for the paint plus 35 per hour. Okay, our output was 265. What's our input? Well, we subtract by 90 first. So I go 265 minus 90, giving me 175 equals 35x. Divide by 35, and we get 5. Well, that's 5, not 8. So, took them 5 hours to do our room. Okay, number 5. There are 20,000 owls in the wild. Every decade, the number of owls is halved. How many will there be in 100 years? So we go f of x equals 20,000. And we're cutting them in half, so we could write divide by 2, but really, when we do an explicit equation of the exponential, we want to times by 1/2 to the x. Okay, so it says that's every decade. Okay, so in 100 years, that's 10 decades, right? That's 10 tens. So really, in 10 iterations of this is what we're looking at. So we go f of 10, not f of 100, times 1/2 to the 10th. Okay, so again, this is one where you want to use your calculator. So 1/2 or 0.5 to the 10th gives us about 0.00097. Times that by 20,000, and that gives us 19.5. So basically, in 100 years, if it continued this way, there'd only be 19.5 owls. Basically 19. And I guess you could have half an owl, right? If it got half to that second. Okay, number 6. The library has 8,000 books and is adding 500 more books each year. How many books will they have in 9 years? So let's go L of B. Oh wait, it's years, huh? So we'll go L of T equals 8,000 to start plus 500 every year. So we want to know 9 years, so that's the input. So L of 9 equals 8,000 plus 500 times 9. So we can go 500 times 9, which should be what, 4,500? Yep, 4,500 plus 8,000 to that, and we get 12,500 books in 9 years if they go at that same rate. All right, so number 7, gym's customers must pay $50 for a membership, plus $3 for each time they use the gym. In a month, Bill pays $131 total for using the gym. How many times did he go? So we're given the output again of what it cost. So we go f of x. Let's actually go G for gym, C for cost, maybe? Sure. That doesn't really make sense, the C for cost, because G of C is cost. So 50 one-time fee that month, plus 3 every time they go to the gym. Now this is our output, so it replaces a G of C. We get 50 plus 3C, subtract 50, that becomes 81 equals 3C, divide by 3, and we should get, what, 27 equals C? So, how many times did he go to the gym? He went 27 times. That's almost daily. Unless he went and came back and went and came back, which I suppose you could do. Okay, a bank account starts with $10. Every month the amount of money in the account is tripled. How much money will the account have in 11 months? So, we've got a bank account, okay, and it's a month, so we'll go B of M equals, it starts with $10. We're tripling it every month. Okay, I like this bank. I would definitely put my money in here. So we want in 11 months, so that's our input, so I'm going to go B of 11 equals 10 times 3 to the 11th. So again, I want to use my calculator for all these powers. So 3 to the 11th gets me, so 10 times 177,147 times 10 would be 1,771,470 in 11 months, which that would be an awesome return of that $10 investment. Okay, that's mad crazy. I would definitely put my money in that bank. All right, the last two. At the start of a carnival, you have a 50 ride tickets. Each time you ride the roller coaster, you have to pay 6 tickets. How many rides until you can't ride anymore? So, we've got a carnival and tickets, C of T. So we have 50. We're subtracting 6 each time we ride. Okay, so how many rides until you can't ride anymore? So if we think about this, that would mean I would basically have to have no more tickets, right? So this would be my output, and we'd want it to be 0. Okay, so we subtract 50, get negative 50 equals negative 6t, divided by negative 6. And negative over negative is positive, so 50 divided by 6 would equal 8.3, would equal t. So basically what that means is, because if I went 8 times 6, that's 48 tickets. So I would have 2 tickets left over, but I'd be able to ride 8 times. Alright, last one here. Nathaniel is writing a novel on the life of Mr. Rideout. He has already written 500 pages and plans on writing 20 pages per week. How long will it take him to write 1,000 pages? So, novel per weeks, he's got 500 already. We're adding 20 every week. Okay, so how long till he gets to 1,000? That again would be the output. So we'd go 1,000 equals 500 plus 20 times W, subtract 500, would give us 500 equals 20W, divide by 20, that would cancel. 50 divided by 2 would give us 25 weeks. So in 25 weeks, he would have at least written. It'd probably take him longer to actually do all the rest of this, the editing and making sure it accurately reflects how awesome Mr. Rideout is and all that kind of stuff. Okay? But there we go, guys. Taking a function from a story problem and using it to evaluate it, whether you're given the input or the output, and how you come up with the other one and recognize what means what. Okay, there we go.